To begin with, I have to admit that math is a boring subject and it can be a real challenge for somebody who is poor at math. But don't worry, you're not alone. In this video, we will be learning the quickest shortcut for solving limit at infinity for rational function. With this technique, we don't have to divide every single term by the highest degree of x in the denominator anymore, just like what your lecturer used to teach you, which is more complicated and have a higher tendency to get your answer wrong. So let us begin with the first step. The first step is to like and subscribe. Just kidding. The first step is to rewrite the function by only considering the highest degree or power of x in both numerator and denominator. As an example, for the previous function, instead of dividing every single term like we used to do, now we just have to consider the highest power of x. As we can see, the highest degree of x in numerator is x squared and the highest degree of x in denominator is x squared as well. Therefore, we can rewrite it into this. After we have done the first step, our second step is just basically determining the final answer based on the situation. We may encounter three possible situations depending on the initial function given, and each of them have different ways to get the final answer. Don't worry, I will be showing examples and explaining for each of the situation. For the first situation where the degree of x is the same in both numerator and denominator, the final answer will be the coefficient of x in numerator divided by coefficient of x in denominator. For example, in this question, we first rewrite the function by only considering the highest power, which is x squared. Since both degree in numerator and denominator are the same, the answer for this question is 4/3. Another way to think about this is we can actually cancel out the x squared. That's the reason 4/3 will be left eventually. Let me show you another example for this. First, we do the same thing, which is rewrite the function. For this question, do not forget to include the square root as well. So, the highest power of x in numerator is square root of x squared. By solving square root of 4x squared, we will be getting 2x and the final answer is 2. Now, for the second situation where the degree of x in numerator is lower than denominator, the final answer will be 0. For example, after rewriting the function, we notice that the power of x is smaller in the numerator. Therefore, the answer for this is 0. Another way to think of this is that after canceling out x in this situation, we left with a constant in the numerator and x in the denominator. As a constant divided by an infinite large value, we will be getting an extremely small value, and that is why the answer for this is 0. Let me show you another example. We do the same thing here, rewrite the function, and simplifying it, we get our final answer 0. For the last situation where the degree of x in numerator is higher than denominator, the final answer will be infinity. For example, we have power of x in numerator that is higher than in denominator. After rewriting the function, our answer for this is infinity. Another way to think of this is that after canceling out x in this situation, we left with x in numerator and a constant in denominator, which is the opposite way that we just found in the second situation. As an infinite large value divided by a constant, we will still be getting an extremely large value, and that is why the answer for this is infinity. Another example for this, rewrite the function and simplifying it, notice that power of x in numerator is larger than in denominator. Therefore, the answer is infinity. And we're done. That's exactly how we solve limit at infinity of rational function by using the quickest shortcut. Now, a quick summary for recapping what we have learned. First, we rewrite the function by only considering the highest degree of x in both numerator and denominator. Afterwards, we just have to determine the final answer based on the three possible situations. If you are used to this method, believe me, you can actually solve it by just only looking at the question without doing any calculation. Thanks for watching, guys. Hope you are still surviving. To be honest, this is my first video ever uploaded. If you get to watch this, means that you are very lucky. If you are interested to watch more videos from me about those boring math topics, please don't forget to like and subscribe. See you guys in the next video.